just a couple of minutes on the spreadsheet that we're using in Assignment 8 to solve this equation. We specify in the spreadsheet the time history of the total forcing, which is F total, and that is the sum of four components: the forcing due to gases, long wave, aerosols in the short wave, volcanic in the short wave, and then the shortwave solar, that is sunspots, the solar cycle. And for each of these, we can specify a constant that allows you to turn the forcings on and off. And for example, here we've doubled the impact of the sun by taking its forcing and multiplying it by a factor of 2. We also have M, which is the thermal capacity of the ocean. So M times delta T gives you the temperature change, the energy change in the ocean since you started the simulation, since delta T is the difference between the current temperature and the temperature you started with. M is the depth of the ocean times the density of the ocean times the heat capacity of water, and when you multiply that by the temperature change, you get the number of joules in a square meter in a year that you have to provide to get that temperature change. And so to march from one year to another, you, for example, if we just start with 1866 here, so we've calculated from 1865 what the temperature change is, and to go forward a year, we take H9, which is the temperature change for the previous year, and add on to that the forcing, which is F10, and the response, which is delta T for the previous year divided by lambda, and then divide the whole thing by E2, which is M. And so that then advances you 1 year and allows you to draw this red line, which you can change then by, for example, making the climate more sensitive by increasing the temperature response to a particular forcing. And the observations are provided on here to indicate a constraint. So it may be impossible to explain the changes in the last century from, for example, solar forcing at all alone. We're interested in just quantifying that a little bit, just fool around with the solar scale and let us know whether you can fit all or part of the line based on solar forcing at all alone. It's not going to be a surprise if you can't, because as we know, aerosols and greenhouse gases have played major roles in forcing the temperature over the last century. So lambda and M change independently. That's also slightly unrealistic, because you would expect the ocean itself to change with changing temperature, but not over the time scales that we're interested in here. So treat M and lambda as independent, and just take a look at the impact of changing the ocean depth and changing the climate sensitivity. Again, just short answers to each of those questions, and send me an email if any of this requires further clarification.